Okay, till now 19 has come, so we'll start. So how was your test, yesterday's test? All of you have given?
Yes, sir.
Yes, sir.
Yes, sir.
Many has got 10. No? So many has got 10. Question was very easy.
Yes, sir. Very easy.
Very easy. Okay.
7 numbers.
Huh? Number 7.
Number 6, sir. Number 6.
Number 6. Okay. Number 6 was a block and tackle system of 5 pulleys is used to lift a load of 2400 Newton by applying an effort of 600 Newton. So here total number of pulleys 5 and effort is applied in downward direction. That means velocity ratio will be, so velocity ratio you are given 5. Load is 2400 Newton. Effort is 600 Newton. Then you are asked the effort needed to lift a load of 6000 Newton. So we will use the concept that velocity ratio and useless load will be same. So what will be the useless load? You can find that real velocity ratio is ideal mechanical advantage. So it is L plus X over E. Two four zero zero plus X over 600. That means X we got 3000 minus 2400. So 600 Newton is the useless load. Now when we change the load, mechanical advantage will change. Mechanical advantage will not remain same. So whatever mechanical advantage is now, at this stage mechanical advantage is 4. But we can't use that because mechanical advantage will change. So when new load is, so when L dash you are given 6000 Newton, this effort we have to find. What will be the new effort? So velocity ratio of the machine will not change, it will remain same. So what will be? So 6600 over 5. So 1320 Newton will be the new effort required. 1320, that is third option will be the correct one. Yes. Any other?
Sir, number 5 of given test 1.
Number 5, the percentage change in kinetic energy.
Yes, sir.
Okay. So in this case, we are given velocity is increased 20%, but there is no change in the mass. The percentage change in kinetic energy when velocity of any object increase by 20% without changing the mass. So what is kinetic energy in terms of mass and velocity? So this V1 is supposed V and V2 is how much? V plus 20% of V. So directly you can write 1.20, no problem. Mass is same. So what is initial kinetic energy? So K1 will be half mv square. K2 will be half m 1.2 v whole square. Mass is same, so m will remain same. So mass will remain same, velocity will only change. Now percentage change in kinetic energy. So K2 minus K1 over K1 into 100 change by original into 100. So this one will solve or it will not solve the problem. 1.44 into half mv square. So half mv square will cancel, so it will become 1.44 into half mv square by half mv square. Half mv square cancel, so 1.44 minus 1 into 100. So it will become 44%. So kinetic energy will increase by 44%. So first option will be the correct one. Hmm? So have you made the cards? Did you submit your cards for Corona Warriors?
Yes, sir.
Yes, sir.
How many?
Here. 4.
51 members.
Huh?
51, sir.
51 only.
I have submitted
One each
4.
or
Sir, I gave 2, sir.
I gave 4.
you gave 2, Puskar gave 4, Aryan, not a single.
Searching, sir, only, sir.
1, sir.
Huh?
0.
So
I have given.
all of you submit
He
today.
received, sir. He received.
Huh?
He received 1.
Only gave Chris.
Okay, next one, suppose one, two, three, four. Okay, we will discuss. So what we in first one, P is power, F is force, V is velocity. Then in this case, all three relations are correct only. P equal to F by V, F into V, or V equal to P by F, or F equal to P by V. So all three relations are same. So answer will be all are correct. That is fourth option you have to pick. Now second one was work done by force is maximum when angle between force and displacement is
0 degree.
0 degree. The energy given to a stone of mass 100 gram in order to increase its linear momentum from this to this. So in this case, work done will be, or energy given you are asked, work done or energy given, whatever it is asked. So energy given will become gain in kinetic energy. So half P square over 2m, that is final minus initial is 0, so initial kinetic energy is 0 only. Linear momentum you are given 2. Mass you are given 100 gram, so we will have to change in kg. So this much. So what will be? Oh, P square over 2 we have already given it, but P square over 2m only. So this much. So 2 joule will be 2 no or 20 joule. 20 joule.
20, sir.
20 joule, no? 20 joule will be the correct answer. Okay. Now lever that can multiply force and speed simultaneously. So there is no lever which can, or there is no machine which can multiply force and speed simultaneously. Either it can multiply force or it can multiply speed. So correct option will be none. That is fourth one. First order can either multiply force or speed. Second order can multiply only force.
Force.
Cannot multiply speed. Third order can multiply only speed. It can't multiply force. So first order can multiply either force or speed, but not together both. Okay, number 6 we have seen. Number 5, 6 also. Okay, number 7 is a crowbar of 120 centimeter So your crowbar is the lever of first order. Here is the phone. Effort we are applying here, load we are applying here. Total length is 120 centimeter. The fulcrum is at a distance of 20 centimeter from the load. Naturally, effort R will become 100 centimeter. So, effort needed, you are asked. So, load into load R will be equal to effort into effort R. So, this load will be 3000 Newton. Newton into 20 centimeter must be equal to effort into 100 centimeter. Centimeter cancel 5. So effort will become 600 Newton. So this will be the answer of 7th one. That is, second option will be the correct one. Okay, so this is your test. Now, calorimetry. Did you solve the problems? Any doubt? Anything to ask? What happened? If you will not solve the problem, calorimetry generally numerical is asked. Only sometimes reasoning type question is asked, sometimes definition of heat capacity this is asked, but most probably numerical is asked in calorimetry. So you are supposed to solve numericals from your book as well as from other book. You have 90% chance numerical will be 10% chance only theoretical question from calorimetry is there.
Sir, number 15.
Number 15. Okay, let me bring the book. Yes, which number?
15, sir. Page 282.
200 gram of ice at 0 degree.
Yes, sir.
So 200 gram of ice at 0 degree converts into water at 0 degree Celsius in 1 minute. When heat is supplied to it at a constant rate. In how much time 200 gram of water at 0 degree Celsius will change to 20 degrees Celsius? Specific latent of ice this much. Okay. So first you find how much heat is required. Heat required to melt ice. That is mass converts. Okay, only it is converting in 0 at in 1 minute. Okay. So that is mass into specific latent heat of fusion. 200 gram into 336 joule per gram. Now, in melting this ice, 1 minute time is taken. So, what is the rate of heating? Rate of heating. Or sometimes we ask power of burner. Who is giving the heat or who is supplying the heat? Power of that burner will be what is the heat supplied and by time, how much time it has taken. So this one will be 67200 and time is 20 minutes. No, 1 minute. So
100 times that of the
1120 joule per second. Now you are asked in how much time 200 gram of water at 0 degree will change into 20 degrees Celsius. So now we'll find what is the heat required. Heat required. Huh? Who is this? Mute your already muted. So heat required to increase temperature of water from 0 degree Celsius to 20 degrees Celsius. So that will be mass into specific capacity into rise in temperature. So mass we are given 200 gram again. 200 gram and we have taken joule per second. So we take here 4.2 joule per gram degree Celsius and rising temperature is 20 degrees Celsius. So how much will come? cancel 42 into 4, 168. So 16800 joule will be the heat required. Now you have to find the time. So rate of heating is same, this much. 1120 joule heat is given in 1 second. So in this much joule, how much time will be required? So required time we have to find. So required time will be 16800 joule by 1120 joule per second, or whatever you write. So how much will come? So 16800 by 1120. 10 cancel. 4, 8.
15 seconds, sir. 15 seconds.
7, 6, 15 seconds, no? So it will become 15 seconds, okay. So in this much time, it will increase the temperature of 200 gram water from 0 to 20. So to increase the temperature from 0 to 20, much less amount of heat will be required in comparison to melt. So whatever heat is required to melt this ice, by same amount of heat, the temperature of same mass of water can be increased from 0 to 80 degrees. Yes, any other? That means we have not done this on numerical. Otherwise, so many problems are there. Okay. Now suppose you are given this temperature versus time graph. What is this message here now? Please copy over, then what can other do? Huh? Rate of cooling is 20 kilojoule per second. Find mass of substance if specific heat capacity in solid state be 2 joule per gram degree Celsius. Specific latent heat of user. Heat capacity of substance in liquid state. Okay. Suppose this is the question. Yes. So here first we are given mass of substance we have to find, and specific capacity in solid state is given this one, 2 joule per gram degree Celsius. So where is in solid state? Which part? Which part of the graph is in solid state? Yes. So this part represents what? Uniform cooling of the liquid. This part represents freezing of liquid. This part represents fall in temperature of solid. So we have to use this part of the graph. So what is the heat lost by a solid? From the graph, what will be? Heat lost by a solid. From here to here. So what is, how much it is? 40 seconds. Time is 40 seconds, and each second is this much heat is released. So 20 kilojoule per second into 40 seconds. So it is 800 kilojoules. This is the heat loss. Now, what is fall in temperature? Fall in temperature of solid. How much it is? The temperature of solid has fallen from 60 to 40. So 60 to 20. So 40 degrees Celsius is fall in temperature. That is theta F we got. Amount of heat you got. You got this much. Fall in temperature you got this much. Specific heat capacity is this much. So specific heat capacity you are given 2 joule per gram degree Celsius. So we'll find, and you know this Q will be equal to mass into specific capacity into fall in temperature. So what will be the mass? Q over S into theta F. So Q is 800 kilojoule. Okay, so 30 more you take that much zero. Joule. This is 2 joule per gram degree Celsius, and falling temperature is 40 degrees Celsius. So degree Celsius cancel, joule cancel, gram will go to the numerator. So how much it will come? One, two, three, 4, 0 will be left. This much gram, that is 10 kg is the mass of substance. Is it correct? Calculation?
Yes, sir.
So mass of the substance we got 10 kg. So this answer we got. Now second part we are asked specific latent heat of fusion of substance. So from which part you will consider? Which part we will get?
From 60 to
From this
120.
part we will get. So now what is the heat loss? During melting, during freezing. Heat loss or heat release during freezing. How much heat is released? How will you find? So how much time it has taken? So from 60 seconds it has started up to 120 seconds. So it is 120 minus 60, this much second. And the rate of cooling is 20 kilojoule per second. So it is 120 minus 60, 60 into 20. 1200. 1200 kilojoule is the heat loss during freezing. Now, heat loss during freezing, we know what is the formula? Mass into specific latent heat of freezing. So this Q is M into L. This L you are asked. So what will be? So this L will be Q over M. So whatever mass of liquid, same mass of solid, same mass of solid here. Whatever liquid is there, that will be converted into solid. So 1200 kilojoule and mass we have got 10 kg. So kilo will cancel, that is, so it is 120 joule per gram. So specific latent heat of fusion of this material is 120 joule per gram. Now this one, heat capacity of substance in liquid state. So where is liquid state? We have to consider this part. So what is heat lost by liquid? So heat lost by liquid is, rate of cooling is this much, and how much time it has taken? 60 seconds.
60.
So again it is 1200 kilojoule. What is fall in temperature? So 100 minus 60, 40 degrees Celsius. So what will be heat capacity? Q over fall in temperature. Because heat loss will be mass into, heat capacity into change in temperature. So as you are asked heat capacity, so this way, if you are asked specific heat capacity, then Q over M will also come here. You are asked heat capacity, so directly we will find heat capacity. So this is 1200 kilojoule by 40 degrees Celsius. Kilojoule per degree Celsius, or 30,000 joule per degree Celsius. That is the heat capacity of that liquid. If you are asked specific heat capacity of liquid, then this heat capacity divided by mass, and mass we have got 10 kg. So divide by 10, that is 3 joule per degree Celsius will come. Joule per gram will come. So suppose in the fourth one you are asked, find the specific heat capacity of substance in liquid state. Then what will you do? Heat capacity by mass, or directly from here only you can find Q over M theta. Okay, time up only. The other teacher might be waiting. So we'll leave up to here.
Thank you, sir.
Thank you, sir.
I've got another
sir.
class 11. Okay, thank you. So whatever is left one, you solve all the numericals.
Okay, sir.
If you are having doubts, then next day you ask. Otherwise, we will start another topic, another chapter that will be light.
Right. Thank you, sir.
Yes.
Thank
Thank
you.
you.